Welcome to video lesson 7, part 1. Today we're going to be discussing lipids. And our list of learning goals for lipids are quite long, and I'll leave you to read that on your own, but I'll point out that ideally in part 1 of the video, we're going to cover all of these learning outcomes. So that's part 1, which is a mandatory viewing. And the remainder will be in class or several parts of optional videos. So the reason we have such a long list for what we need to learn today has to do with answering the question, what makes a lipid a lipid? And it's because lipids are very diverse, there's a lot for us to learn about them. In fact, unlike carbohydrates, lipids do not share a common structure or a common empirical formula. Rather, lipids are very diverse. And lipids aren't necessarily classed together by their structure, but more on something that they can't do. And that is, lipids do not dissolve in water. Another thing that lipids share in common are that lipids contain more energy per gram than any other biological molecules or any other class of biological molecules. What this means is if you're to break the bonds of a lipid, they can release more energy than other types of molecules. Because lipids are so diverse, it's not surprising that their functions are very diverse. But some of the key functions of lipids with respect to the human body include long-term energy storage, insulation, helping keep things warm, buoyancy, helping keep things afloat, protection and cushioning. Most of your organs are surrounded by fatty deposits that help protect them. Formation of cell membrane. And for signaling purposes. This includes intracellular, within a single cell, and intercellular, between cells. So there are three main subclasses of lipids. The first one we're going to look at are fats and oils. This is your long-term energy storage, your buoyancy, your insulation. The second we're going to look at are phospholipids. These are what help form your cell membranes. The last one we're going to look at are the steroids, which are used for signaling. So if we look at fats and oils, they have a lot in common and then a few differences. In terms of what they have in common, their function, long-term energy storage. They also, like all lipids, do not dissolve in water. They all have a similar chemical structure in that they have what's called a glycerol backbone, which is attached to 3 fatty acids. And we'll take a closer look at what that means. So that's what they have in common. If we want to look at what they have different, we can look at the fats on the left, oils on the right. Fats are solid at room temperature. In contrast, oils are typically liquid at room temperature. As well, fats are typically from animals. Some common fats you might know are lard, blubber, and one you may not think of, milk. That's where we get lovely ice cream and cheeses from. In contrast, oils are typically from plants. If you think about it, you can probably list all sorts of oils from plants, including things like olive, sunflower, vegetable, and so on. And what makes one solid at room temperature and one liquid at room temperature is the fact that fats have saturated fatty acid chains. Whereas oils have unsaturated fatty acid chains. And what that means, we will explore in class when we actually look at the structures, or if you continue on and watch the other videos. That's where we're going to leave it for now. If you have any questions, I hope you come see me or ask me in class. Otherwise, have a great day.